So those are some of the titles that you can see in data science today. Is there any title that's surprising to you? Company just keep on creating new title. And for myself, I actually switched from data scientist to be quant researcher. And even within quant researcher, you could be a quant researcher in UX. You could be a quant researcher in market, like market researcher. You can be a quant researcher in finance. Those trading company, they hire a lot of quant researcher. So depending on what you are, this is slightly different how you apply your skill. So the title can get very messy. And some companies start to hire more economists if they want to do causal inference or if they want to understand the macroeconomic impact, especially like Amazon has economists. So what they do is somewhat similar to the other data science role. It's a quant role. So identity crisis is real in industry. So how to solve that? I think the best way to solve it is just to look at what they do. So if you look at what they do every day, you have a much better idea what your role is. So if you look at what people do, there are 3 tracks of data science. One is engineering track. Basically, engineering is the process of getting data, making everything else possible. They prepare the data for everything else. So there are 3 parts of engineering. One is data environment. You're going to set up the data environment, including data storage. And if you working on like online real-time data, like Uber, the data has to be sent in real time and have feedback in real time. And data management is how you're going to move data around, how you store the data and move data around, what type of storage you want to pick. Like if you have a lot of unstructured logs that you don't know how to use it yet, you don't need to query it like every day. In that case, the data will be stored in a very different storage than the data you know you're going to query very often. Data management, make all those decisions, and also how you connect to specific API to grab data. They can use a different tool for their support. If you call someone, that data can sit in a third-party vendor's database. So how you connect all of this, bring it together, and how often you want to bring it. It's like every hour or every day. So all those decisions is data management. And then production. Production has 2 sides. One side is when you get data, because everything has to be automated, getting data, using data. If you get to the edge, it has to be automated. If you have model, you deploy the model, that needs to be automated. So that's the other side of it. So the beginning side is getting all the messy data together and clean it. And the end side is after all the pipeline, you know which model to use, implement it in your system. So both sides are engineering, and there are different crafts analyzing the data. And then the second track is analysis. Analysis track basically is to get some data insights. It's more about you get some pattern and get some correlation. You can show it, visualize it, maybe build some dashboard. The key of this track is you have to know the domain knowledge very well. You need to know your product and the company very well to give the right recommendation. Depending on how often you do dashboard, if you most of the time do dashboard, automate dashboard, it's more like a BI engineer, but the line is very blurred right now because of the dashboarding tool. Modeling and inference, this is a track. At the beginning, most people think data science people do, which is not true. Modeling inference, there are also slightly different. Modeling is more about algorithm, like machine learning, because most of the machine learning model today, they care more about prediction, not explanation. They don't need you to provide business insight by predicting the outcome. They just want you to build a predictor that can work very well in production systems. Sometimes you need to design the right model to work in the production system. So there are 2 different things. Prediction classification is more about getting the outcome right. Explanation is more about inference. You need to find the key drivers. You need to explain the data, like feature prioritization. If you have 25 features you could build, the PM come to you and they can only build 3 of them, which 3 they should build. So those are the inference and explanation question. In causal inference, other than A/B testing is used a lot. Another area when you do causal inference is when you want to have a product change, you really want to know if that product change increase or decrease frequency of user behavior. So that's when you want to use causal inference. Not every product change can be measured by A/B testing. So this is an example only. If you look at the keywords, technical keywords in general for different title, because since title can be very different across different company, because depending on which company you work, it can be very different. You could be an analyst, but you do modeling, advanced thing. But in general, analysts, they do like basic stats. They do data visualization, and SQL is very common across different roles. From the top to the bottom, this is ordered by how much engineering you will need of the data pipeline. From the top, it's closer to the beginning of the data pipeline, like data infrastructure engineer design the structure, the data environment, and then data engineer clean the data, set up everything, and do the data modeling. We will talk about data modeling in the afternoon, but data engineer are those people who do the data modeling, make sure data is useful for analytics, for further analytics and modeling. And then BI engineer. Today, BI engineer and data analyst are like combined into one role. In the old days, BI engineer, it's called business intelligence engineer. What they do is basically just building dashboard. That's when there are not like no Tableau, like Power BI. Before those tools exist, there are BI engineer role. Now, since we have all the BI dashboard tool, usually analysts will, after they analyze the result, they will just build the dashboard and schedule it so it can be automated. But that requires data engineer handle all the data process. In order to, when you need to have a real-time dashboard, you have to query the database a lot. And you can't calculate that. If the calculation is a lot each time, that will consume a lot of computation. What you need to do is you have to organize data, make it ready so you don't have to calculate. It has to be aggregate, pre-aggregate. So it's a lot more requirement for data engineer if you combine this BI engineer and data analyst role. And then data scientists, those will use more stats. They also use data visualization. They do a lot of experiment like A/B testing. A lot of data scientists do A/B testing. That's a big group of data scientists in industry. And research scientists really depend on the company. Like I know Amazon may have people from stats background, PhD or some quant background, but research scientists at Google basically is PhD in CS. They do deep learning. That's Google Brain. Most of people there is research scientists. And applied scientists, this position started, I think, 3 or 4 years ago. The first company I saw have that position is Amazon. Basically, this position is built to fill the gap between research scientist and machine learning engineer. So if you have a new model, you want to implement it, make it in the production system, sometimes research scientists will not have the production skill to put it in. They create this applied scientist role that can fill the gap. A machine learning engineer is a pretty engineering role. It's in the end of the pipeline, you implement the model into the production system. So if you put everything together, you probably see different version of this online. You can put it together as this pyramid of data science types and need. On the bottom two bars here is basically data engineering, because that's the foundation of everything else. That's when 3-4 years ago, many startups at that time would make mistake by hiring data scientists first and then hire data engineer. They didn't really have people build up the basic infrastructure. I was the first hire at Netlify as data scientist to build their data science team. And then when I joined, I realized they need data engineer. I spent 2 years building the data pipeline there. So that's the biggest mistake a startup can make when they build data science team. Data science for human is when you have that infrastructure, you want to understand your data, you build dashboard, you know your metrics, and then you can start to do A/B testing, you can start to do causal inference. And based on all the knowledge, and then you can build something for machine. So that's data science for machine. Everything can be automated at that time.